In this video, we're going to use related rates to solve problems involving angles or shadows. And they tell us that an airplane is flying overhead at a constant elevation of 3,000 feet. A man is viewing the plane from a position 4,000 feet from the base of a radio tower. The airplane is flying horizontally away from the man. If the man is flying at a rate of 600 feet per second, at what rate is the distance between the man and the plane increasing when the plane passes over the radio tower? So first of all, let's draw this scenario. We have a man standing here. We have a tower that's on this side that is 3,000 feet. Now the tower is not changing. It's a constant, all right? So an airplane is flying overhead at a constant elevation of 3,000 feet. A man is viewing the plane from a position 4,000 feet from the base of a radio tower. So (4,000 feet from the base of a radio tower). So actually, this isn't the radio tower. This is the 3,000. This is the airplane flying overhead. So they say it's a constant elevation. So this is actually the airplane. I'm going to go ahead and put the airplane here. And the tower would actually be like right here behind him. So the tower doesn't really matter for this problem, because they're saying that the tower is basically behind him, right? A man is viewing the plane from a position 4,000 feet from the base of a radio tower. So 4,000 feet right here, but we can't really say 4,000 feet because this is changing as the airplane is flying, and they said it was flying away from him. Right, a plane is flying at a rate of 600 feet per second. At what rate is the distance between the man and the plane increasing? So they want to know this distance here. They want to know S. We're going to call this S. This is the distance between the man and the plane. And this is the X distance, which they tell us is 4,000 feet, that they want to find it at 4,000 feet. So a man is viewing the plane from a position 4,000 feet from the base of a radio tower. The airplane is flying horizontally away from the man. If the plane is flying at a rate of 600 feet per second, at what rate is the distance between the man and the plane increasing when the plane passes over the radio tower? So actually, the airplane is flying in this direction, which would be the same as x. So they're telling us that dx over dt in this problem is equal to 600 feet per second. So we're just kind of piecing all this together. 3,000 feet, that's a constant, that's for sure. X is 4,000 feet, but it's not constant. It's changing because of this speed. And then they're asking us, we want to know ds over dt. So here's what we do. We go ahead and start writing out the Pythagorean theorem. We know we're dealing with rates here that we're going to have to figure out. So we're going to write the Pythagorean theorem out. Say x squared plus s squared. Nope, x squared plus 3,000 squared is equal to s squared. And then we're going to take the derivative of this equation with respect to time. And when we do that, we end up with d over dt of x squared plus d over dt of 3,000 squared equals d over dt of s squared. Now the derivative of x squared with respect to t is going to be 2x dx over dt. We're doing that implicitly because our variable we're taking the derivative with respect to, which is time, is different than our distance value there. So we have to offset that by using implicit differentiation. Derivative with respect to time of a constant, that's 0. So I'm going to just say equal here. That's really just 0, so it's gone. Derivative with respect to time of s squared, that's 2s ds over dt. We can actually divide 2 out of each of these pieces, and that would be x dx over dt is equal to s ds over dt. Now they want us to find ds over dt, so we're going to divide each side by s, and we get x over s dx over dt is equal to ds over dt. So then what we want to do is we want to well, we know x at that specific moment was 4,000 feet. But we don't know what s was at that moment. So what we're going to do is we're going to use the Pythagorean theorem to find out what s is at the specific moment that they were talking about. Which would have been, if we take 4,000 squared, plus 3,000 squared, and then square root that, we get 5,000. So S was actually 5,000 there. So now we can figure all this out. I'm going to write that up here. We're going to say ds over dt is equal to x, which was 4,000, over s, which is 5,000, times our ds over dt, or our dx over dt, which they said was 600 feet per second. And when we do that, we get ds over dt is equal to 480 feet per second. So the distance that the man is from the airplane is changing at 480 feet per second at this specific moment. So at this specific moment when the man is 4,000 feet from the airplane, or from being directly under the airplane.